working in Southern Africa. And I got exposed to the systems of Southern Africa through an IGERT program. That those programs don't exist anymore, but it was an NSF-funded project that essentially provided funding for PhD students to work in interdisciplinary ways on applied existing problems. So we started off my PhD program by going to Southern Africa, getting immersed for 7 weeks, and getting exposed to a variety of issues. And then I had the absolute most amazing time developing a dissertation. And I've been working in Africa ever since 2006. So I'm talking about this because this is a lot of where my heart is at. And I'm going to talk about how with a recent project, we leveraged all of that experience, all of those years of having worked in this system with emerging technologies and interdisciplinary approaches to address issues of land degradation and vulnerability on multiple scales. So very quickly, I will position myself as a geographer, talk about why I do the research I do. I'll jump into this project, and if I have time, I will talk about a paper that is actually kind of in press in Science, so I'm very excited about that. But if I don't have time, you'll hear about it later. So I am a human environment geographer, okay? So for those of you PhD students, you know how this goes. You have to position yourself as who are you, where do you fit into the bigger umbrella of geography. And I'm so excited to be speaking to fellow geographers. In my department, there are only 3 of us. So it's beautiful that I get to speak to other fellow-minded geographers. So the overarching theme that I work on are these multiscalar quantitative assessments that explore the relationships between local dynamics and global processes. And I do that at multiple scales, right? I work in North Carolina, I work in Peru, I work in Southern Africa, I've worked in Nepal. And what I like about sort of this strand of geography is that we typically tend to tackle policy questions, complex issues that allow us to put to use the expertise, the emphasis of geography on multiscalar approaches and fieldwork and interdisciplinarity and collaboration. So why do I do this work? Well, I do this work because, like I said, I got exposed to these issues in a very unique way that was absolutely phenomenal, but also in the grander scheme of things, we essentially are in a state of transition as far as increasing human populations, right, and the decrease of the amount of natural ecosystems or ecosystems that haven't been affected or transformed by humans. And as that percentage of ecosystems that are unaffected or transformed is decreasing and population is increasing, we're kind of reaching this critical threshold, right? And that critical threshold has bearing on sort of people's day-to-day ability to make a living, right? To make a livelihood. So when you bring in climate change, natural climate change and variability, anthropogenic climate change, and you bring in all the socioeconomic and institutional and governance and all of these other processes going on, right? And you start thinking about, well, what makes a community at risk? What makes people more or less vulnerable? So I'm interested in exploring those pathways, more so because a recent analysis, and this is just a simple map, but I chose it because it essentially showed that that impacts from extreme weather events hit the poorest communities hardest, typically, right? So typically the poorest countries are most vulnerable to the damaging effects of hazards, whether those are floods or fires or droughts, or you name it, heat waves. And these communities typically have a lower coping capacity, need more time to rebuild and recover. And we've seen this with Florence in North Carolina, right? But given that I decided to focus today on sub-Saharan Africa, another really big thing that makes research in the lesser developed countries, or sometimes they used to be called the global South, interesting or even more necessary than ever before is the fact that it's been widely recognized that a lot of communities are trapped in a spiral of vulnerability where you bring in this degradation of ecosystems, this transformation of ecosystems, and you bring in the fact that a lot of these communities are very resource dependent, and you bring in climate change, and you bring in all these things, right? And you bring in the fact that a lot of these communities are impoverished as well. So then that begs the question of how can these communities, how can folks basically overcome this spiral of vulnerability and land degradation? And just to kind of show you that, and as I said, I've been working in these systems, asking these kinds of questions at the interface between land degradation, global environmental change, and community and vulnerability at multiple scales for a long time. And as it stands right now, I'm actually part of this project that's funded by the Global Environment Facility in the amount of $2 million that kind of got routed through Conservation International. And this is an amazing opportunity to see all of the stuff that I've been working on more in a theoretical way, basically really come together with attention from the UN Convention to Combat Desertification, because in our work to approach what we call land degradation neutrality by 2030, and to meet some sustainable development goals of essentially eradicating poverty and hunger and all of these things, all of these strands of information and these strands of research on degradation and vulnerability and climate tend to come together. So with the ultimate goal of improving land condition and improving the conditions of vulnerable communities. So that was just to kind of give you an example. This is one of the things I'm working on at the moment that was a perfect sort of a result from all the previous work that I had been doing. But what I promised I was going to talk about today were these multiscalar approaches to modeling degradation and vulnerability. And as I said already, as geographers, we are the people to be doing this. And I am excited to be one of those folks that gets to work on these cool things. And that's a lot because of what I said, interdisciplinarity, and also our focus in the land system science, remote sensing community, of connecting the people to the pixels. So I feel like we have a great advantage, right? We bring in some skills in meeting the challenge of connecting environmental dynamics that we can measure from satellite remote sensing, for example, to household and community level dynamics. So that's where a lot of my contributions and my work sort of fall into. So now, I'm going to move on and talk about this project that I'm going to talk about, where all of these little pieces that I just talked about, and again, takeaway is we have environmental degradation, we have global climate change, natural anthropogenic, we have people everywhere, lots of people, some people that are very resource dependent with relatively low ability to cope, that are also poor, that are also disadvantaged, and this applies that we can look at these in any communities. But this project called Kazava actually was started from PhD level friendships, guys. So those of you sitting in that room right now, or your respective rooms at home, and you're all PhD students going through this great program at UNC Charlotte, someday you're probably gonna work with those people that are in this program with you. Myself, Forrest, Andrea, and Joel, and Lynn, and the four of us were PIs on this NSF grant. We were friends in grad school. We were friends during our PhD. We all worked on different things in Africa, in this community. So then we came together, wrote this proposal 3 different times until it got funded, so 3 different years. But then we were able to bring all students to the field and bring in postdocs and do some of this. So the work I'm going to talk about from here on out is the result of this collaboration with all of these folks here. So you'll see some of the names on the papers and things like that. Okay, so what was our objective? And as I said, many of us, myself included, worked in that region for a long time. So we basically wanted to find a way to bring all the pieces that we had worked on and and I'm a biophysical geographer, human environment. He's a statistician. Joel is a social geographer, and so is Lynn. And so we essentially brought different things to this project with the objective of facilitating an understanding of how livelihoods, land use, and the environment, both in terms of climate and in terms of land uses, land cover, are changing in this large transfrontier conservation area in Southern Africa. So again, the project is called Kazava. It stands for Kavango Zambezi Vulnerability and Adaptation. I'll come to the Kavango Zambezi piece in just a second. But the overarching theme was that we adapted this vulnerability framework from Turner et al. That identify these linkages between the social and biophysical components of a socio-ecological system to basically reflect these properties specific to exposure, sensitivity, and adaptive capacity in a combination with a livelihoods framework. And we wanted to identify leverage points that can help us, identify how we can then help work with stakeholders to mitigate land use decisions and landscape degradation in the face of uncertainty. And although I didn't specifically make that very clear, we actually worked with a lot of communities on the ground, with a lot of NGOs. We partner with the universities in each of the countries, of the 3 countries that comprise our focus out of this region. We actually worked with partner universities and so on and so forth. So the Kavango Zambezi Transfrontier Conservation Area, as you can see on these maps, and I can't get my mouse to move on to this other screens. There it is. Right, so it's the largest transfrontier conservation area in the world. It's the size of California, about 440,000 square kilometers. It was created back in 2013 with the goal of connecting protected areas across 5 different countries, Namibia, Botswana, Zimbabwe, Zambia, and Angola. There are still strongholds for a lot of megafauna, basically. So the idea was to create these wildlife corridors to allow elephants and giraffes and buffalo to move across state boundaries, following the water with the rainy season, dry season. So it's essentially it was essentially an entity meant to not only protect wildlife and allow them to move more freely, but also help communities essentially benefit more directly from cohabiting with that wildlife. And by essentially providing them conservation incentives and providing them with some revenue from the tourism that this region brings to this part of the world. And these communities that we worked in, that you see labeled here on this map, are all community-based organizations. So they're CBOs, where the governance of the natural resources and the wildlife populations that do bring tourists to these regions allow communities to go into these joint venture agreements with safari operators and hotels to essentially benefit from that. Now, all of that has stopped due to COVID, but that's a different talk. So why we chose this region and why I guess we got this NSF grant, because we set it up pretty nicely. We had worked in these communities, so we knew, we knew the region, and we were essentially trying to, in trying to measure that interplay between livelihoods, land use, and global environmental change and how they affect vulnerability. We were able to take advantage of these climatic gradients that exist. So the study area spans an annual rainfall gradient of about 400 to 1,000 millimeters, strongly controlled by the ITCZ. And then it also comprises a heterogeneous semi-arid savanna that ranges from open woodland up in the top to scrubs and grasslands and more degraded grasslands, following that woody component with increasing mean annual. Okay. However, this broad trend tends to be disrupted by fires, by land management initiatives, grazing, livestock, soil nutrient characteristics. So it's not only a rainfall-driven gradient, but it results in some significant land cover mosaics. And the livelihoods are also incredibly varied across political, institutional, and biophysical dimensions. And as I said already, these are resource-dependent communities where cattle raising is the most important part of livelihoods. Then rain-fed farming contributes a lot to people's day-to-day lives, as well as fishing, natural resource collection, and like I mentioned, tourism. So we have a nice sort of gradient of livelihood strategies and land use mosaics. So, okay, so there's that. How do we integrate between the people, the natural, and the social scales, the multiple scales, and all of these levels of measurements? So the approach we took was this multiscaler integration that we wrote a paper about, in which we actually went through and discussed how we were able to make this successful, considering the fact that we are working across the natural systems and social systems that span countries, climate gradients, land use gradients, land cover gradients, all of these things, right? And the way, and again, in order to understand kind of what's happening here on the ground at the individual, at the small level, we sort of start out with an ability as remote sensors and land system scientists and geographers to look at these trends at regional scales, continental scales, regional scales, and kind of like narrow it down step by step in a way so that we can actually measure various processes across these different spatial scales and levels of organization within the system through iterative and adaptive management of essentially all of this data. And this is probably a familiar graph that you all might have seen before. But as you can see here, we essentially are bringing all of this stuff together in the natural system with the social system in something that we call land function. So we see the way land functions and the way the land is able to provide goods and services to a community, right, as a natural interplay between processes that happen in the natural system and processes that happen in the social system. And they kind of go hand in hand with land use and land cover. So if you're part of the land system science community, this is definitely sort of you know, the meat of it all, right? Land's function, we look at land as its ability to provide these goods and services for human and other populations, wildlife populations. And we can quantify that, right, using a variety of socioeconomic and environmental types of things, especially derived from remote sensing. So what am I talking about here in terms of some of these land functions and thinking about how land cover, land use overlap to provide goods and services? We're talking about things like agriculture, which is a land use, but we see it from remote sensing as, say, clear ground, and that provides a service of food provision, and so on and so forth. And then the idea is that we can measure these, right? We can measure these, we can look at them, we can quantify them over time using different types of measurements from remote sensing, for example, or field collection. So that's kind of what I'm talking about. But to narrow it down into, so this land function and how we conceptualized of it and how we operationalize this is we conceptualized the vulnerability, right? So how vulnerable is a community or a household in the face of what that community is exposed to and how sensitive it is. It goes through these land functions. And then we look at adaptive capacity essentially as a modifier on land function and vulnerability that allows us then to get at that connection between people and pixels. So it allows us to say, start drilling down into something like household vulnerability by looking at exposure, sensitivity, and adaptive capacity. And I'll define these real quickly. So vulnerability would be a community's or a household's level of resilience or ability to bounce back from being exposed to a hazard, right? That would be the simplistic approach. And the way we conceptualize of exposure is a spatiotemporal nature of environmental characteristics. Adaptive capacity is the ability to cope and adapt to systems dynamics, and sensitivity is the degree to which a household is affected by exposure, but how that exposure gets mitigated by adaptive capacity. So, wow, and at this point, I wish I could see your faces. I'm sorry I don't with this setup here, but this is, so I kind of went a little bit into it, and these boxes are empty for now, just to explain that essentially what I said in the beginning is that we use structural equation modeling to tie all these pieces together. So we essentially took these four components that are our structural model. So in a way, we conceptualize of how the environment, people, institutions, governance, natural human capitals, financial capitals, all of these things, how they interact together. So we kind of put them in boxes, and that's our structural. So we have four structures here that are interacting, and they're interacting more or less statistically through correlations and regressions. Think about it like that, okay? And then we went out in the field and measured a bunch of stuff. So all of these boxes on the outside, these are called measured indicators, right? These are covariates in this model. And then, so we went and measured all of these. We measured various things in the field. We measured things using remote sensing. We measured certain things using participatory mapping. And then we measured certain other things using household surveys. And then we essentially extracted these indicators out of our different pieces that were collected in the field, and essentially then we can start populating these boxes. So just to kind of give you an example of how this works is, so as I said, exposure is that spatiotemporal quantification of environmental variability, if you want, okay? So one example here would be the rainy season length, or the number of dry spells, or the median anomalies in NDVI, whatever it is, distance to the floodplain. So these would be essentially exogenous variables that we can measure from remote sensing, from precipitation data that affect how a household may respond if it's a drought or if it's a flood. Sensitivity would be something like crop yields, or cattle owned, or resources gathered. So you can think about a simple relationship here, that land function, land system analog I was talking about earlier, where the number of months a household, say, is food insecure in a year, which is what's in this box here. Again, these are all measured, okay? We've measured these indicators. So the number of months a household is food insecure is going to depend on whether that rainy season was of a normal length, or whether it's a shrunk rainy season, for example, and crop yields. Okay, and I'm not, again, gonna bore you necessarily with all of these arrows and things, because that's not the focus. Other than to say that then in adaptive capacity, as I said, we use a sustainable livelihood framework that is predicated on 5 capitals: financial, social, natural, physical, and I forget one, another capital, essentially employment, so things that have to do with income, right? So then we asked folks a series of questions about these kinds of capitals, and we were able to extract indices and then start quantifying the model. And again, please don't freak out. This is not the final iteration. We're still working on the final iteration of this, but essentially all of these pathways, they receive a weight or a coefficient value that basically quantifies which one of these pieces is most important. And the key piece here, and I'm going to stop at this and move on to something else, is so what we want, what this structural modeling approach allows us to do is essentially take the 4 structures that we were talking about: exposure, adaptive capacity, sensitivity, and try to understand which one would be most important, which one do we have most leverage on. Remember I said that we were interested in finding leverage points of how we can decrease vulnerability. So which one of these levers is potentially more sensitive? Where would we have the most impact, right? Because we can't go fix the climate, but what we can do, and what our model is showing, is that adaptive investing in increasing people's adaptive capacity is where we're going to get the biggest bang for our buck. So to kind of, or to put it a different way, if we have all of these pieces, right, and we look at something like food security, oftentimes when there's a prolonged drought, what ends up happening is people are given food subsidies, and that would essentially be an intervention on their current vulnerabilities. They're vulnerable, they are hungry, we give them food subsidies, or we give a community food subsidies, they get over it, get through that season. However, if we actually make an intervention on sensitivity, something like conservation agriculture, which allows people to put different crops together and things like that, then we are making an intervention that will have a bigger sort of leverage.
Narciska.
Yes.
Hey, do you have time for a question now, or is your about the SEM, or would you prefer I ask it later?
I mean, it's up to you, but if you're interrupting me, I'm going to stop my timer here.
Well, since you've stopped your timer, can you go back a couple of slides? I just want to ask one more.
Where? Okay. Back here or here?
Both of those here. So I've done some SEM analysis myself, and it looks like you're using it sort of proactively. I've always used it, you know, you get this big chunk of data, and then you use the SEM to figure out what's important and what is modulating other things. It looks like, how did you decide on this architecture? Is it hypothesized and just massaged to an SEM, or is it based on some preliminary data? Or
it's all based on, so all of the, no, actually what you're seeing here, but again, like I said, this isn't, so the paper that we did in Land, this paper was all, the simulations were done based on preliminary data, because we, like I said, we had been working here for a long time. So we made hypotheses based on a very strong understanding of the system. You may say we were biased in making these assumptions. Some of them actually, we were surprised by some of the results. But yes, typically it was based on hypothesized relationships.
Okay, and so when we look at the things that you were able to measure, I imagine that before you can treat your data with an SEM, everything needs to overlap. For example, if there's like one of your pieces here is you measured the highest education of any member, right? And then for that person or that data, it should overlap with the number of hectares cropped, FI category, and crop yields. How did you get all the different kinds of data to be ascribed to a single row, which is what I would think you would have to do, right?
Yeah, so essentially, like I said, we have a statistician on the team, and his name is Forrest Stevens. And he is literally, he lives and breathes statistics. And yeah, so he basically did all the magic behind the scenes here, more or less. But yeah, everything got transformed. So all the various types of measurements were transformed to be able to be fit into this model in a similar kind of way. And I don't have graphics actually for you.
Well, I was wondering if you were going to say that we actually mapped people and we did, sort of a overlay analysis to figure out that for a given landowner, what their yields were, how long their rainy season was for a given year.
I will explain. Yeah, let me go through, because I'm not done here. I will explain. Hopefully I'll get to some of that a little bit as I keep going. But yeah, so essentially we treated these things a little bit sort of one by one to some extent. The environmental stuff we treated in one way, and I'm about to show that. And then all the other sort of variables that came out of the household surveys, they were all normalized and log normalized and basically brought to be the same kind of, actually a lot of them were put in just indices 0 to 5. So we use quantiles to break them up into high, medium, low, and things like that. So there's different. We've done it in different continuously and more in a ordinal scale like that.
All right. Thank you so much.
Yeah. So so let me resume my thing here, but I don't know where I'll be. So anyways, it's just to kind of give you an example of why, yes, we were doing this in a way proactively, but not really, because realistically we are using data we collected. So, but the idea would be to understand kind of where should we be making, or where should communities be making investments on these leverage points. So I was going to spend a couple minutes talking about how we got the data, right? Because I kind of jumped right into it and I didn't talk about our sampling or what that looked like. So we had 3 types of data collection in the field: household interviews, and all of those we had about 240 per country times 3 countries. So I think we ended up with 780 or so. And we surveyed 5 villages in every one of these CBOs. So we have 15 villages, 240 households in each, and the surveys mostly captured all the normal things that we ask about demographics. We asked people, we had a 9-question small section about food security, which is why we were able to tie that to food security. And then we had questions that measured household livelihood capitals, the stuff I was just talking about: economic, human, natural, physical. So all of that. And then a team of us, I was on this team mostly. I spent most of my time doing the biophysical data collection. And this is where we use those emerging technologies, the UASs. So we actually very creatively got a cheap DJI Mavic, well, a set, because we had 2 teams collecting these at all times. So DJI Mavics, onto which we actually rigged using a little 3D printed bracket and some Velcro, a $3,500 Parrot Sequoia multispectral camera that basically has the same spectral characteristics as Landsat or RapidEye or Sentinel data, more or less. I mean, they're different widths, but we can use them together. And we essentially did about 100 of these flights across the communities. So we were trying to sample vegetation, the land covers, and we also did in situ data collection using transects and woody intercepts. The idea with this, the biophysical piece, comes back to what I talked about, that degradation and bush encroachment, and the fact that we really wanted a way to try to get at bush encroachment, to get at that degradation. I'll come back to that. And then the third piece that we collected in the field were, we used participatory mapping and engaged in essentially resource mapping. So what we did is, in the household surveys, we asked people about what kind of resources they collect from the ground and where they go for these resources. So they named them, and then we brought enumerators and key informants along, mapped all these areas using GPSs in the field, and then created these polygons that represent different resource areas as elicited from the household surveys. And this paper just got published in Applied Geography. There's a lot more detail in here that I'm just skimming over, but that allowed us to then look at bringing it back to the land function piece that I keep talking about, right? To bring it back to essentially, get a quantification of the intensity of household resource use across these 3 different countries, so Botswana, Namibia, and Zambia. So we were able to put this together, and then we were able to, this isn't coming. So then we were able to start looking at intensity class, so land use intensity, and that's another paper that is coming out here soon. So the idea was so we were able to tie the household surveys to the remote sensing through this lens of participatory mapping to try to get to those land functions. But what I wanted to spend a little time on is the exposure, right? Because I said I am more of a remote sensor, and I'm all about multi-scale remote sensing, geospatial modeling. So I want to talk a little bit about that. So bringing it back around to degradation and vulnerability. In this kind of an ecosystem, degradation is essentially bush encroachment. And it's one of the most difficult types of land degradation to map from remote sensing, because it appears as a greening signal on your remote sensing imagery, right? But in fact, that greening signal is a degradation, and it's really difficult to tease out where you have bush encroachment, versus where you have not, where you don't. And essentially, this was part of what we were trying to understand and figure out good remote sensing proxies that would help us get at that degradation and measure those land functions, because a degraded savanna is no longer able to support livestock, nor is it really able to support the wild animals that depend on it. So that's kind of how that all comes together. And so the approach here was this multi-scale remote sensing that essentially entails linking between UAS imagery all the way to AVHRR imagery. And you'll probably be like, what in the heck? How are you guys doing that? I'm just going to say we haven't finished doing it yet. So this is also still work in progress. But just to take away that because of the kind of degradation we're talking about here, that is only really visible sort of vertically in the vegetation signal, right? Because bushes, they are the same tree species as the trees usually, or a lot of times. So spectrally, they look very similar. So the only way to figure out what's bush and what's tree of the same kind is to look at that height. So that's why we used UAS, and I'll come to this in just a second. And then the idea is to use, so we use the UAS to sample these different types of covers across these gradients. And then we want to statistically fuse that with ever coarser, meaning sort of the wider wider extent both in time and in space, to try to get at those more regional changes. So part of that exposure, as I said in the beginning, is looking at these more continental trends and understanding what is the climatic and environmental sort of signal that we are able to measure from remote sensing. So this is an example of using about 1981 to 2018 or so data from CHIRPS, the Climate Hazards Group Infrared Precipitation Station data, to look at the mean rainy season to see has that changed, how has that changed over time, and to look at these drier. Are any of the communities we're working in really getting drier? Are they getting less rainfall, or has the length of the rainy season changed, right? So everywhere where you have these hashes, those are statistically significant reductions actually an increase in the dry decades in the 10-day periods, and then a decrease in the rainy season length. And that becomes really important, right? Because we are trying to understand, if we're trying to understand differential vulnerability of households and communities, that's going to be important information. So kind of to show you what that looks like, if you drill into these communities we worked in, and I said we had 5 villages of about the same size across the 3 different countries, then we can actually look and quantify per community with this coarser resolution data, right? The equivalent of AVHRR, it's the type of resolution where you have a significant reduction, for example, in the length of the rainy season. So that would be that. And then we can start looking at other types of predictors for that model. So those boxes, my measurement boxes that were in that SEM earlier, and start looking again across my communities using the coarser data, the average distance of households to the river. And this can influence their ability to do basically flood agriculture, which is a really big type of agriculture in this region. It's called Molapo agriculture. So that where you actually get a flood, you are able to farm better. If you don't get the flood, then you're not going to have the soil humidity and so on and so forth. So there's that. Or things like vegetation productivity. And this is where the NDVI comes into play, right? So we can quantify this from HVHRR. We can quantify this from time series of Landsat data. And again, do the same kind of thing. Look at these changes, right? These snapshots in dry vegetation productivity and how that may be changing over time, so that we can then have these. So here are my villages, my 5 villages zooming in. Here are all the households that we surveyed, about 240 in this community in Mashi in Namibia. And then we essentially are isolating out a household, putting a 1 kilometer buffer around it. And within that 1 kilometer buffer, we extract these metrics. Okay, so we're putting the numbers in those boxes up there in my exposure, and then bringing that into the model so that we can have essentially a profile through time on these various exposure predictors that is coming into the model. So hopefully that explains some of your question. And then, Doug, and then the next tie that we do is through, so that gives us that exposure, but then the other piece is, how is that environment changed? Is it degrading? Is it staying the same? What's going on in there long term? And how does that overlap with how people are using resources? Are people maybe using resources in some of these areas, right, that are delineated because people said they are using the resources here? So we essentially used that information to delineate them, and then we can start looking at sort of the footprints of these resource areas using remote sensing imagery and trying to get at that degradation piece. And so just to kind of give you an example of how the UAS stuff works with the resource mapping. Oh, so I guess I failed to say that these are the mapped resources. And so then what we did is we went and flew, and this piece I failed to say, but we actually took a large portion of our flights, and this is maybe not the best example. The other community, we had a lot more UAS flights inside these resource areas. So the idea was to fly outside of these resource areas, look at those resource intensities, and then see if we can pick up that signal, that resource use signal, that degradation signal from the remote sensing imagery. And so with these flights, to give you an example of the kinds of amazing data that they were able to give us, is here's an Esri map. Here's the size of an AVHRR pixel for that same area, a Landsat, right? So how much information can we glean at that scale from this Landsat image? You'll probably, here's a rapid eye, and then this is the resolution. This is the kind of data we were able to get with the UAS data. And as I said, we were flying a multispectral camera on there. So that multispectral camera matching essentially the multispectral bands on rapid eye, for example, or PlanetScope, which we actually used more PlanetScope than rapid eye, and Landsat. Then we can kind of start tying these things together. So for the UAS piece, like I said, we did about 200 by 200 meter flights with these transects that gave us information about canopies. So we took actual in situ data about the canopy structure, about the ground cover, and then we used structure from motion algorithms, pretty standard photogrammetric algorithms to process all of that data. So those 100 flights. Again, we have the multispectral data that allows us to then get NDVIs, but importantly, allows us to get digital surface models that then give us things, information about canopy, so the height of canopy. So we extracted canopy height models and delineation of trees, and with the goal of essentially figuring out what's a tree and what's a bush, what's a scrub, and a scrub is anything less than 3 meters. So then we're able to, for these sampled locations, we're able to say what's a tree and what's a shrub. And then basically we're able to bring that data over to Landsat or Rapid Eye and so on and so forth. So what we were able to do with this was essentially use a pretty standard, relatively speaking, UAS setup, flying an RGB camera at the same time as the Parasequoia camera. So we essentially got twice the data from the way that we had our platform set up. So we were able to create essentially 5 sets of point clouds, but one set from the RGB imagery and one set from the multispectral imagery. So we essentially derived point clouds from the 4 bands on the Sequoia, green, red edge, and near infrared, and essentially showed that with the near infrared band, interestingly enough, and the paper is down here, you guys, it's one of the master students that ended up running with this analysis, but the near infrared band gave us a huge amount of promising structural metrics that allowed us to delineate canopies, and essentially basically classify vegetation not only by spectral information, but also by these structural classes, right? And this is what we were kind of looking for, and that's the stuff that we're now working on integrating into coarser resolution and wider coverage satellite-based remote sensing. So that was the piece where, again, we brought together household interviews to allow us to figure out where people are using resources. And then we went with our UAS platforms, flew the inside, outside, different places, right? And essentially to get at the one piece, that's vertical structure of the vegetation piece that we couldn't get at in any other way from just satellite-based remote sensing Landsat or PlanetScope or things of that nature. So that's a really cool approach, and I think piece that we were excited to be able to do, and we're still working on. To again tie back to degradation and that environmental exposure in the model. And I only have a few minutes. I can stop here. I have 3 minutes according to my timer, or I can quickly go over how we essentially kind of unintentionally, because through some of the questions that were asked in the survey, right? And I said we had these surveys, lots of them. So they gave us, so we had asked some questions about food security, basically how many days in a normal year defined by rainfall, of course, in that case. So in a normal rainfall kind of year, how many do you ever experience food insecurity? And if you do, then what kind? So then we would, if somebody said that they had experienced food insecurity, then we would kind of go with a set of nested questions within that. And we also asked people questions about human-wildlife conflict, which, again, a slightly different story, but different topic, but a big issue in this part of the world with a lot of the conservation efforts going on here, right? So human-wildlife conflicts are on the rise. So we were able to basically take data on food security, self-reported crop depredation, and rainfall, and essentially look at, create a conceptual model that linked the human-wildlife system and its effect on human food security, right? So we were trying to understand, first of all, across the 3 different countries, who gets most predated by wildlife, which one of the communities. It was pretty much always Namibia, because they're sort of sandwiched there between 2 national parks right here. So this one here, it's one of the smallest communities, national park, community forest, and this is actually inadvertently a wildlife corridor. So they get a huge amount of crop depredation, especially by elephants. So anyways, again, along the same lines of leverage points and figuring out where, how can conservation work with climate change, with increasing populations in these parts of the world, and trying to contribute a little bit to shifting that conversation away from sort of that citadel conservation, and acknowledging the fact that the people on the ground are bearing some huge costs from living with this wildlife. So we were able to essentially identify that the crop predation is mostly offset by really by simply gather foods from gather foods, or from social services programs such as welfare programs, but not so much by income from other sources or livestock or some of the other things that we would think that would help people cope with that conflict again. And then lastly, when we look at food security, crop depredation, and climate, that's when the situation gets really, really tricky in this part of the world, because we essentially, if we hold everything else constant, households that experience crop depredation are much more likely to be food insecure, right? So essentially, and if you add these modifications, these quantifiable changes in the length of the rainy season or the number of dry decades, right? We see that there's a significant increased trend of dry days. Then it's essentially subjecting these communities to a triple whammy effect. In any case, just wanted to conclude here really quickly by saying that with this kind of an interdisciplinary approach that combines remote sensing, social geography, social sciences, we can quantitatively test these vulnerability theories while accounting for land dynamics through that land function quantification at multiple scales, and we can make inferences and connections about these different sort of pieces. And UAS data is providing useful in scaling and tying together these multiple scales across the study area. And like I said, there's still so much kind of still going on and coming out of this effort. But I'm going to stop here. Thank you. And I'll take any questions come out of this so I can see people.
I have a question. So, will you consider the government policy since the population vulnerability caused by the climate change can
yes,
also be
absolutely.
compensated by the government for green? Yeah.
Absolutely, and this right here is essentially part of that, right? So we are looking at we are looking at any remittances and looking at any ways that the government is trying to offset. They're not necessarily helping offset for drought. I mean, the only way that the government is helping offset for drought would be through food subsidies, what I said, right? And even that comes from not necessarily the government, but the reason we're spending so much time actually working on this human-wildlife conflict is because we think it's a really kind of in-your-face tie between climate and what people are experiencing on the ground that government officials can wrap their head around. And people do actually they have to file, if they lose a crop, they file to essentially get money from the government for that loss, but there's no scheme really out there that's going to give them a remittance or any kind of money for loss of crops due to droughts yet. But we are accounting for how the different governments, the Botswana, Namibian, and Zambian governments are. So we are well aware of that, those kind of policies.
Okay, thank you. And
I have a question regarding the US.
Sorry, regarding what?
Regarding the US survey, so your study area is quite huge. So how you decided that which area you are going to do with the US, you are going to use drones?
We and the goal was to fly most of our surveys in those resource areas that people had identified, or inside and outside. As much as we could, we tried to go inside and outside of the resource areas. And I mean, you're right, the study area is enormous, right? And we were only able to get 100 flights that are about 250 by 250 meter. They are very much just a tiny little sample, but we tried to stratify them by where we had a mapped resource area, as well as by that woody savanna to tree, grass to tree gradient. So we try to get a bunch of grassland sites, a bunch of woody sites, and a bunch of woodland sites. I didn't talk about that, but yes, if you look at that Calaric paper 2020, we actually in the slide that I was showing you here, we essentially sampled across that woody gradient here. So grass, shrub, and tree. So everything was done with that in mind, with us kind of being able to come back. And so what we're doing with that is that's a paper we're working on right now, is to create fractional vegetation cover models from the UAS data that we can then apply to Landsat. we're hoping that if we can apply those as essentially training data to Landsat, and we can do a fractional vegetation cover through time on the Landsat time series, then they will have served their purpose, because that's what we were anticipating being able to do with that. So just to train a model to identify what's woody, what's grass, and what's tree, and where they're mixed.
Thank you.
And that's, you know, I say this to my class when I teach my drone class. I say, look, drones are nice, but they're not going to be able to give you that much. I think where drones are powerful in what we do as geographers are really for the tiny little pieces, right, to give you that sampling. And they did. I mean, think about how we do land cover, land use mapping before drones. We would go out there with our GPS and do our SciPec training sample protocol, and we would get 1 point of this is a woodland and this is a shrub. Now, with drones, at least we get a much sort of, you know, a little more than we would get with a transect or a quadrant or, you know, just a normal training sample.
I have the other question. So you said you use a drone-based multispectrum sensor and the Landsat imagery. So how, because based on my experience, they are not that comparable, not only in the resolution, but also even though they're in the same resolution, the value could be different. So, so how do you standardize them, or?
Yeah, and that's like I said, there's a lot going on there too, and we are making that tied to Landsat through PlanetScope imagery.
So do you use that to estimate the productivity, or?
Yeah, so we can estimate productivity. The NDVI would be the #1 thing. So we can estimate productivity, and I didn't include those slides. I had some slides, but I took those out. But yeah, so we can estimate vegetation productivity from the multispectral camera on the drone, and we've done this. And object-based classification actually works best to take the productivity data that we derive from the UAS imagery, and then essentially use that as a training set for satellite remote sensing.
Oh, okay.
That's what we've done with it so far, but there's, I'm sure, more stuff that can be done.
Okay, thank you.
Mm-hmm.
Well, thank you so much for that incredible presentation, great visuals, a lot of information, and I wouldn't be surprised if you have some follow-up. We've gone past our 2:30 deadline, so anybody who needs to go, feel free to go. If you have any more questions, Narissa, are you willing to stay on for a few more minutes?
Yeah, I'm good. I'm good. Yeah. Happy to stay on for a few minutes or not.
You know me, I've got tons of questions. So now that you've identified, you know, I love to talk about outcomes, like what are the end products, right? And then you have analysis that gives you ideas about what the levers are. Are you able to make like spatially explicit analyses or visualizations like maps of vulnerability? And then from there, are you able to create predictions using your model? So given IPCC scenario X, these are the areas that light up as being below some metric, and for a different climate scenario, lighting up.
We have not done that. We have not made it that far. Honestly, it was, we have still a lot that we haven't gotten it. We definitely haven't made it to thinking about scenarios, predictions in the future. But what we have, and we also have not made yet maps of vulnerability for this region even. Okay, so we're just like taking it one piece at a time, and it typically, you know, a couple of these things, the food outcome stuff were spearheaded by a postdoc. I mean, that was what he was doing. So he managed to get a lot of papers out of this already, but just from that angle, you know, the Salerno papers, right? But yeah, so as a group, the sort of the core group, we are working on making vulnerability maps. We would like to be able to do that. And then the other piece that we kind of have been able to do, and that's under review right now, is to make predictions to make predictions on where we see some of this resource intensity essentially showing up, and extrapolating that beyond the places we sampled.
Okay.
But that's under review. So yeah, so the short answer would be yes, but no, we also don't have anybody on the team that is probably gonna ever take this and make scenarios, IPCC type of future scenarios, but I think that would be really cool.
So are you able to, so another thing I'm always interested in understanding how to go from knowledge to action.
Yeah.
So you've got this fantastic, you know a lot about this thing from a 40,000 foot level. Is there a way to get the word out so that it can be incorporated into how people choose their livelihoods or how they manage their lands?
Well, that's the goal, and so we made an actual story map of the whole project that we shared back. And really, do you guys want me to?
Oh, yeah, you can put the link in the chat, would you?
Yeah, so we actually made it. It's pretty cool. I thought it was pretty cool, but I can never get this link to it. I'll send it to you. Oh my gosh, it always gives me an intern. If you just Google Kazava story maps, it'll be the first link that opens. But for some, I'll put it in the chat. So we made this and we sent it to everybody, and we maintain a listserv, and we keep in touch with everybody out there. And again, we work through the universities. One of our she couldn't be a co-PI, but Lynn Cassidy, who's at the University of Botswana, she's on the ground. We have done multiple dissemination efforts. We've gone back, so we kept money in our budget for dissemination. We've actually taken these maps back to some maps back to communities that mapped out their resource use, intensity, and stuff like that. And as it so happens, I actually have a Fulbright Scholar Award, and I'm going to be living there. I was supposed to be there this year, kind of, because it always comes back to this, right? We went every year for 4 years. And every time we would show up and we would talk to the folks, and we would keep in touch with them over the course of the year. But every time we'd show up, they'd be like, oh, you guys show up once a year and you tell us about all this cool stuff you're doing, and then you leave, and then we don't hear from you for a few months. I'm like, yeah, because this stuff takes a long time to work through. It's like, oh my God, just getting the surveys right. You guys understand what it takes to get 780 surveys from paper, because we chose to do them on paper, because people said that if we showed up with tablets, then it would make people feel even, the disparity between us. And so we did it in paper. And then, so all of that, it takes time. So essentially I said, okay, well, we'll show you guys that we're committed. And so I actually have a Fulbright that I was supposed to be on. So that's another way to engage. And guess what? Because of this stuff, we did a couple of training workshops at the University of Namibia, and they actually got a huge grant from UNEP to start a degradation monitoring initiative using UAS technology, in part due to the fact that we were able to show them that, hey, you can actually measure these things from photographs. You can get because this bush encroachment issue, I mean, I worked on it for my dissertation. I didn't have any conclusive result. I couldn't say it was this, that, because it's so hot. We couldn't even measure it for real. Like, you can't, we couldn't. So there's that aspect. And I have students that are still interested in working on that and still working on that. So in a way, we're trying. There's always the question. We're trying. We send the stuff over. We go back. I'm gonna go and live there with my child for 5 months next year, if all goes well, starting in March, and I'll be doing all of this. So I mean, I don't know how much more else. I mean.
No, it's always a challenge. So I'm interested in hearing how successful people tackle it, and it sounds like it remains a challenge, and you're taking personal initiative to go back and stay tuned. There's more likely to happen.
Sure.
Yeah, great.
So, Dr. Narcisa, other than collecting the information personally from people, do you get any database from the government side, or is there any database exist in the country that you can just go and open that website and you can get the data about the households, agriculture, or land use, etc.?
Yes, you can get census data from the government. We've gotten agricultural census data from the government. I definitely rely, well, we used to, not so much. We can get rainfall data. There are some climate stations. We can get some of that information, but to be quite honest, between the fact that a couple of our team members are on the World Pop project, and I don't know if you're familiar with that, World Pop, it's essentially a global initiative to, I think it's worldpop.com or .org, I forget. But it's essentially a global initiative to take census data and turn it into gridded population, gridded poverty, gridded demographic data. So to be quite honest, we don't necessarily need to go to the country level for those data because we can use the gridded derived data sets from like WorldPop for the kind of modeling that we do. But yes, before this project, I actually, when I was doing my PhD dissertation, I went there several times. I spent a lot of time one year when I had a dissertation improvement grant, and I went to all the offices. I would just go and say hi, and I try to tell them about what I was doing, and I try to build and I still keep it. I still email and say, hey, here's a paper, or hey, do you guys want to give me this year's data worth of flow data or stage data or whatever I need, and they still kind of remember. So there's a huge component of making those relationships. It still doesn't mean that your research will be used. May or may not be used in policy making. We all want that, but I don't know.
I have a quick question. So, so your team used the Mavic Pro. So I'm wondering whether a multi-spectrum sensor is built in the Mavic Pro, or you just add on.
No, that's what I was saying. I was showing, or maybe I used the word jerry-rigged, and maybe that was too much of a word. But we essentially, no, we attached the multispectral camera underneath the Mavic.
Oh, okay.
We 3D printed this little bracket, and then we used Velcro to essentially tie a little battery pack underneath the Mavic. Put the camera here, the sunshine sensor on top. And we kind of got the multispectral camera powered off of this little battery pack. So at all times we were collecting data. We were collecting an RGB data set, which was much higher spatial resolution. And the multispectral, it always ended up being about 10, 11 centimeters per pixel.
Well, that's pretty cool. I think 3D printer.
What's that?
I think that is pretty cool. Our life need a 3D printer.
Wow. Yeah, I actually did this in my drone class on Monday, because I have a fixed wing EB, but it's in the shop because it broke. So I was trying to teach my class about collecting multispectral data, and I rigged it on my Mavic again. So if you guys if you ever want to come down and see, and now I have a lot, if you guys want to hear about UAS stuff, I mean, that would be a different talk. I can just talk about now, because I have a LiDAR drone right now on my DOT project that we're doing a lot of stuff with. But yeah, so if you ever want to check out or come out with us in the field, you guys are more than welcome to. It's kind of far away.
This LiDAR drone, is it you purchased it, or it is again like?
No, I basically convinced the NCDOT that they need this LiDAR drone, and I get to use it for 2 years. No, they will use it, and it's really cool. They definitely want, I'll be honest, when I wrote the grant, I was gonna be like, they're not gonna want it. Because we purchased it, UNCW purchased it, I purchased it, and I was kind of hoping that by the end of the project, they'd be like, we move on, we want something that they really want it, because it's really useful. It's because a lot of the projects that they do are in these forested wetlands around here, and you can't get that ground. You can't really get a good high resolution ground response, and the LiDAR drone does an amazing job, so it sucks.
Have you found that fixed wing performs differently than like a quadcopter?
Oh yeah, I love my fixed wing. I've had my fixed wing since 2016, 17, and it actually broke down for the first time 3 weeks ago, and I sent it up to SenseFly in Raleigh. I have one of those SenseFly EBs, and they were amazed. Apparently, it's one of the oldest still functioning drones that I got so many flights out of. But I love it because, you know, the only downside with it is you need a wide open area to launch and land. But other than that, I mean, I've taken that thing to 4,400 meters in Peru, and it did amazing. So I love it.
I'm building my own, and I was hoping to put like a GoPro in it and do some aerial surveys, that kind of thing. And it's in the background. I think you can see about right there.
Wow, cool.
Working on it, but
super
it's just interesting to see the differences between, like, for Cages we use the quadcopter from DJI, and then I'm looking at the fixed wing for myself.
Okay. Well, I mean, I like the stability of the fixed wing and the high quality data it does actually collect. But the quadcopters are fine too. They just give you a much smaller. You can map a much smaller area with the quadcopter.
So I have one more question. In the wetlands or in the forest area, if you which is better, aerial LiDAR or the LiDAR mounted on a UAS? Which one is better? What do you recommend?
Sorry, what kind of LiDAR, on a UAS or what kind?
Like you said, UAS with LiDAR. Is it in the forest area or in the wetlands area?
Yeah.
Which one is better, aerial LiDAR or a UAS with LiDAR?
Oh, I mean, if you can fly the UAS LiDAR, you get way denser of a point cloud, so you can really penetrate through the trees a lot better than with the aerial. Even the QLC LiDAR, that kind of stuff, the freely available LiDAR for the space.
Yes.
Yeah. I did a paper. There is a paper I did in Stanford just a couple months ago that showed the comparison between aerial LiDAR and the UAS. But I'm happy to talk more about that. I didn't know what you.
Well, perhaps we should let you go, and thank you for the invitation to.
Yeah, for real. I'd love to have you guys down for a visit.
And if we can make it happen, if we really would like to take a field trip out to UNC Wilmington to see what you're doing, that would be really fun. And
I would love to.
6 people or something like that. Try to make it worth your while.
We can do a Friday or something along those lines. I usually have my lab meetings. But we could even meet somewhere and do some flights, or we can bring I have the fixed wing, the LiDAR drone, and several quadcopters with different setups.
All right, so Cages crew, let me know. Maybe put your heads together and see, and then I'll see if I can make that happen, arrange the vehicle, etc. All right.
Our DPI group would love that, I think.
Okay.
Yeah, we love to share because we put our heads together, we do cool things.
Yeah.
So we're not selfish around. I mean, I'm not, because I have too many ideas and not enough people to work on them. So.
Perfect. All right. Well, thank you so much. It's been great for us, and we really appreciate your time.
All right. Bye.
All right. Bye-bye.
Thanks for coming. Bye.